Good morning everyone. Today we are going to learn about requirements workflow and defining requirements, which is one of the most important topics in software engineering. Before developing any software, we should clearly understand what the customer actually wants. If the requirements are not collected properly, even a well-developed software project can fail. In this session, we will discuss what requirements are, why requirements engineering is important, and the activities involved in gathering and documenting requirements. Now let's understand the requirements workflow. Requirements workflow mainly takes place during the inception and elaboration phases of a software development. The purpose is to understand the customer needs before development begins. During this phase, developers interact with clients, ask questions, clarify the doubts, and collect all the required information. The final goal is to prepare a clear understanding of what the software should do so that everyone involved in the project has the same expectations. So why do we need requirement engineering? The first reason is to prepare a high-level specification of the system. Secondly, it helps developers and customers reach a common understanding about the software requirements. Another important purpose is to identify and prioritize the customer needs. Many people are involved in giving requirements. These people are called stakeholders. Stakeholders include customers, end users, managers, maintenance engineers, support staff, and our sales teams. Each stakeholder may have different expectations, so collecting the requirements from everyone helps build a better software system. This slide shows the software requirements meta model. A meta model represents how different requirement documents and models are connected. It follows UML notations, which are commonly used in object-oriented software engineering. Here we can see that the use case model, vision document, supplementary requirement specification, and glossary are all related. The tree's relationship helps us connect requirements with corresponding use cases, making it easier to verify whether every requirement has been implemented. So meta model follows UML notation. UML grouping mechanism and contains group of UML modeling elements. The anchor icon indicates that the thing at the circle end contains the thing at the other end of the line. Requirements workflow detail. Now let's see the detailed activities involved in the requirements workflow. There are three major activities. The first activity is finding actors and use cases. Actors are the users or external system that interact with the software. The second activity is detailing each use case, where we describe step by step how the user interact with the system. Third activity is structuring the use case model, which organizes all use cases in a proper way. Other supporting tasks include identifying functional and non-functional requirements, prioritizing them, and tracing requirements to use cases. Three major activities: finding actors and use cases, detail the use case, structures the use case model. Other add-on tasks: finding the functional requirements, finding non-functional, prioritize the requirements, and tracing the requirements to use cases. So next one is importance of requirements. So requirements are the foundation of any successful software project. So requirement engineering includes collecting, documenting, analyzing, and maintaining software requirements. So that one of the major reasons for software project failure is poor requirements gathering. If users are not involved during requirement collection, the final software may not satisfy their needs. Therefore, effective requirement engineering improves communication, reduces development errors, it saves time, and increases the chance of project success. So next one is defining the requirements. So requirements are mainly classified into two types: functional requirements and non-functional requirements. Functional requirements describes what the software should do, such as user login, searching the records, generating the reports, and process payments. The second one is non-functional requirements, a specific property or constraint of the system. So it specifies how well the system should perform. Examples include speed, security, reliability, and performance. So one important rule is that requirement should describe what the system must do and not how it should be implemented. So the implementation details are decided later during software design. So let's understand the difference using an ATML example. Functional requirements include checking whether ATM is valid, verifying the customer PIN, and allowing cost withdrawal within the daily limit. These describe the actual functions performed by the system. Non-functional requirements describe quality attributes. For example, the software should be developed using C++ and the ATM should verify the code and PIN within 3 seconds. So remember this rule. Functional requirements tell us what the system does, while non-functional requirements tell us how well the system performs. The difference is very important and is frequently asked in exams. So in today's class, we learned about the requirements workflow, the need for requirement engineering, the activities involved, and the difference between functional and non-functional requirements. These concepts form the foundation for developing reliable and successful software systems. Thank you.